Are we at peak pre-training? Wagner Santana is a staff research scientist and master inventor on the Responsible Tech team. Wagner, welcome back to the show. What say you?
Given that we have, or we don't have methods for detecting synthetic data, maybe the peak is already in the past, right? Because now people are realizing, and maybe we've done that already.
Volkmar Willig is Vice President AI Infrastructure Portfolio Lead. Volkmar, how about you?
I think we need to give it a couple more years.
And Abraham Daniels joining us for the very first time as a Senior Technical Product Manager on Granite. Abraham, welcome to the show. You're now an expert on Mixture of Experts. Tell us what you think.
I wouldn't say that it's over. I guess I'm 100% sure that's over, but I think we're less reliant on it going forward.
All right, awesome. All that and more on today's Mixture of Experts. I'm Tim Huang, and welcome to Mixture of Experts. Each week, MOE is dedicated to bringing the breaking news and analysis you need to understand what's going on in the world of artificial intelligence. Today is another jam-packed episode. We're going to talk about the latest release out of Granite, weird ways of stealing models, and NVIDIA's tiny supercomputer. But first, let's talk a little bit about pre-training. As many of you may know, this is the kind of week of the big machine learning conference, NeurIPS. Ilya Sutskever, a big, actually prominent thinker and kind of intellectual and entrepreneur in the AI space, gave a keynote talk in which he claimed that we are at peak pre-training. That essentially pre-training is over, and to create improvements on AI going forwards, we're going to have to employ a bunch of different methods. And I guess maybe, Wagner, I'll start with you because I think you nodded towards kind of one solution that Ilya mentioned in his talk, which is synthetic data. Are you ultimately really optimistic? I mean, it kind of sounds like you've got kind of almost a paranoid view that we might already be living in synthetic data land, but tell us more about why synthetic data might be a way forwards if we think that we're literally running out of the data that we need to do pre-training.
In fact, I'm concerned about it because when we see like the projections of how synthetic data is populating the web, we don't have methods for actually detecting and doing pre-training, saying, okay, this is synthetic, this is not synthetic. So that is why I answer that way, because we may already been pre-training models with content generated by LLMs, because we don't have a way to properly filter when, or good methods for properly filtering when something was generated by an LLM or not. So that's my concern. So we may be living already in the world that pre-training is happening or is using data generated by LLMs.
Abraham, maybe I'll kind of turn it to you because I know you work on the Granite team. I think one really interesting kind of aspect of all this is that a lot of the data that we've relied on for pre-training in the past has been open data, right? People use Common Crawl and what have you to kind of like pre-train their models. And I guess part of the idea here is that like in this world where basically all the data is available, and being used, basically proprietary data becomes a lot more valuable. And I'm curious about how you think about that at Granite. I mean, I know, IBM's taken a real stand towards openness, and I'm wondering if that also applies to how you guys think about the data sets that are going to become more and more important here.
Yeah, so great question. In terms of data, I think like we've done a lot of work in terms of partnering with third parties to be able to backfill some of the more specific like domain or enterprise data that's key to not only our models, but our commercial roadmap. So I think that's going to be like a really big pillar for us is, where can we find data that may not necessarily be open source, but that is kind of central to our roadmap, focusing on domain specific models. But kind of back to what I said earlier in terms of where pre-training might not be over, but I think there's a shifting paradigm in terms of how we inference our models, more specifically what's called test time compute. And you're starting to see this with some of the newer models that came out, like ChatGPT o1 as well as Qwen, where we're less reliant on the static knowledge that we get as part of our pre-training, and really focusing on how do we make models more capable at inferencing, having them think a little bit more about their answers as opposed to using a system one thinking where the first answer they get is what they respond with.
Yeah, and I think that's a really interesting approach. Is almost kind of like the real action now is almost data-less in some ways, right? It assumes the pre-training happens, and then all the real optimization is going to be like doing these kind of inference tricks, which is going to be a very, very different way of thinking about some of this stuff.
Yeah, it's a little more system two thinking. So reflecting on your answer, having the ability to go back, change your answer, or better understand if there was a misstep in your thought process.
Volkmar, maybe I'll bring you into this discussion. We've had you on a couple shows at this point. I think I'm starting to get the Volkmar vibe on how you answer questions. I don't know if I'm reading too much into what you said, where you said, well, we got a few more years. Do you think this is just hype? This is just Ilya doing his thought leading? Like, we're not really at peak pre-training. This is like, he's describing a trend, but it's probably more hyped than anything else.
So I think what he's touching on is, and this has been a trend over the last couple of years, that the amount of information you can get in the open, effectively we downloaded everything and we trained everything into the models. And so we are now at a point where, and Wagner mentioned that, how do you differentiate data which is computer generated versus what is actually human generated? And that's the fundamental question, right? And so first of all, we assume that human generated data is good and machine generated data is maybe good. And I think that is not true, right? So human generated data is misleading and is wrong. And particularly if you just scroll the internet, what do you know, right? You just download some stuff and people make stuff up and you train that into the model and you declare that's reality. So I think we are at a point, and Abraham touched on this, and I'm a strong believer in the system one, system two thing, where we need to actually test the data which we download from the internet or which is synthetically generated. And that's kind of like test time compute behind it, right? So I spit out a bunch of answers and some of them are wrong, some of them are right, and I pick the right one. So I can apply the same mechanism to stuff I download from the internet. And now it doesn't matter anymore if it's, human generated. And we kind of assumed humans, generate good data. And so anything we could download was good. I think we are now in a world where we can produce so much bad data at a really high velocity that we actually, when we are creating those pre-training data corpora, we need to actually go through the data, sift it, and actually classify it as, this is garbage and this is true. And I think the only way to do that is actually using large language models. And the same thing we are using for test time compute, where we are, picking the right answer, we will probably have to apply to the data corpus we train in. I think still the pre-training, is the system two, where, I don't think for a long time, but I just recall. And I think in any case, we will have to build that core model, and the model architectures change and how we are training changes. And so I don't think pre-training per se goes away, but I think that the focus will shift. The pre-training is the basis so that you know something, and then you can apply it in a system one type, where you're spending more time thinking.
Yeah, just like it gets you to the first base basically, but like going further is going to depend on all these other
Correct.
techniques.
I think the further is the hard one, and this is where I think reinforcement comes in. We are actually discovering new knowledge, and we will publish that new knowledge. And I think new knowledge will not necessarily come from humans all the time, but it will come from models.
Yeah, I love this observation that in some ways the gains from just having more data have been so strong for so long that the incentive has just been dump more data. We really don't care. We don't really look too closely because the more data we put into this magic machine, it just gets better and better and better. I guess kind of you're saying is that the meta is kind of shifting now, that we are concerned about quality. And then I think the nuance you're adding to it was very interesting, is that that synthetic data may very well be much more high quality than what we get out of humans, which I think is an interesting outcome. I guess, Wagner, how do you think about that? Because I think in some ways, from the point of view of a responsible AI or responsible tech ethics person, I think that the bias has always been towards human-generated content. We say, oh, well, we don't trust the synthetic-generated content because who knows? It might embed all this bias and it might have all these problems. Do you kind of buy what Volkmar is saying? That actually, we are now rapidly approaching this point where, hey, our kind of long-standing, kind of prejudice in favor of human data is actually misplaced?
My concern is that if we think about the most popular LLM used now, or by people to generate content, could be OpenAI's ChatGPT, right? And if we have this data, and I agree with Volkmar in terms of the quality. It's difficult to assess quality of data, human generated or synthetic data. But imagine that we have a lot of people using ChatGPT to create data, and then this data is used again to pre-train ChatGPT version +1, right? So now the biases that the data had before are coming in again to the model. So my concern is that this auto like this feedback of bias, considering that we don't have yet good methods for detecting when the data was generated by an LLM. I think that's my concern. How to prevent that the bias that a previous version has to come in to the next version of any LLM pre-training on these data.
Yeah, for sure. I mean, I think this goes to the question of just like, I guess quality is a little bit under theorized in this context, right? Like, what do we actually mean by better quality here and against what types of tasks? I guess, Wagner, you've got certain concerns, right, around this data. I guess if the main use case is like, I don't know, math or something like that, right? Like we may actually say that the synthetic data is actually better, but it really depends on use case in some ways. I'm going to move us to our next topic, I think. We had a big launch this week, which is Granite 3.1. Abraham, you're on the show in part because you're from the team. Do you want to kind of tell our listeners, I guess, what's coming out and what people should be paying attention to?
Yeah. Actually, what's already come out. So as of yesterday, we released Granite 3.1, our latest model in the series, in the Granite series, family of models. So it's built on top of Granite 3.0. And as part of that release, we've pushed out our Granite 8B Instruct as well as our Granite 2B Instruct. Our Granite 8B is really kind of our workhorse model for, 80%, 90% of use cases, enterprise, as well as any sort of specific domain cases. What we're really excited about in terms of our workhorse model is that we've seen great improvements in instruction following as well as multi-step reasoning. Along with our Granite 8B and 2B dense models, we've released a suite of MOE or mixture of expert models. These come in 1B or 1 billion as well as 3 billion. And these are really focused on resource constraint environments, any sort of low latency applications, edge computing, which we'll talk a little bit about in terms of the NVIDIA. And the big kind of release or capability that we're launching with Granite 3.1 is we now support 128 context length. So what that really means is we can, input larger, tokens into the model. So what that supports is, long documents or multiple documents to support QA, as well as any sort of, code bases, so you can put in a full code base repository, and it also lends to more LLM-powered autonomous agents. Along with our language models, we've released our Granite Guardian series. So these are our Guardian models that support detection across a number of different biases and hallucinations. So specifically, the most recent Granite Guardian 3.1 supports function calling hallucinations. So again, a great feature for agentic workflows. And then lastly, as part of our release, we have pushed out our Granite embedding models. So these are efficient, robust models that support semantic search. They've come in 4 sizes as across English and language. And in terms of language, we support all 12 languages included as part of our language model. So we're super excited to have them out in the market. They can be found on Hugging Face as well as our Watson X platform. We also have them on a number of different partner platforms. So Ollama, Replicate, they'll be pushed to NVIDIA as well. And we're just really excited for what's to come. And we're looking forward to scaling out our MOE models in 2025, as well as introducing some multimodal capabilities.
Yeah, that's awesome. So a lot there, obviously, to go through. I mean, I think maybe the first thing I'll kind of bring you back to talk a little bit about is context window. I know that was a big part of the launch, a big part that kind of IBM is, I think, touting as part of this release.
Yeah.
Can you paint a little bit more of a picture of kind of like what this means for, again, like enterprise customers? Like what does a long context window actually mean in practice?
So it's basically how many words you can input as part of your model inferencing. So our initial models were 4K, and there's really no one-to-one in terms of, tokens to words, but we'd say about 1.5, if you will. So that's 128K context length would be about 300 pages, give or take. And what that really means is part of that is now you can ingest, multiple documents that supports any sort of particular QA or legal documents, anything that spans multiple pages or multiple corpuses of information. And then it opens up a couple different capabilities for users. Again, more specifically, LLM support, agent support, which is, prominent. Kind of like the buzzword right now is agents. Otherwise, it also supports, new possibilities around repository level code understanding, as well as self-reflection. So we kind of talked about it a little bit, where you can now start to ask your models to reflect on the input or the output and start to have that little bit of system two thinking, where it can start to better understand its answers and potentially shift its answers if necessary.
Right, for sure. Wagner, maybe one thing I can bring you to talk a little bit about here is I think the models that are focused specifically on safety are pretty interesting here. I think for a very long time, I think one of the concerns, just to put it out there, around open models is, well, they're going to be used for all sorts of bad purposes, right? And I think one of the really interesting questions has been, can you achieve openness and all the things that we like out of openness while still ensuring kind of like safety in the model ecosystem? And I take it that these models that are safety focused are kind of like an attempt to do so. I guess my question for you is, like, do you think that we're on track? Like that eventually we will be able to have our cake and eat it too, to get the openness and the safety at the same time?
I think so. And if we compare even the topics that we discussed in the last episodes, always when we talk about certain attacks that we discovered, they are mostly connected to proprietary models, right? Because when we see that happening for open models, people contribute and people try to fix it, right? We have a community around these assets. So I think that in that sense, I think that the open source strategy makes a lot of sense, in my opinion. And it's an interesting way. And the way that, for instance, for Granite, the Granite Guardian is structured like also from the very as a first barrier in terms of what is being sent to the model, right? Working at the prompt level, and also after the generation, I think that that's a good strategy also. And we see that also in other open platforms, like in LlamaGuard, they have like an open source model to detect also these types of harms, right? And I think that again, when we see new ways of attacking, as the ones that we discussed a few episodes ago, they are because we don't know a lot about architecture, about the code, about the flow of information and generation, and how prompts are going in and the outcome is coming out. So that's I think that, again, open source, I think, is a good approach to tackle this.
That's right. Yeah. So final element I want to kind of touch on before we move to the next topic is, I think, Volkmar, you work on AI infrastructure. And I think one of the observations we talked about a few episodes ago about all the announcements Amazon was making was there's sort of one interpretation that in the future, like infrastructure wins because kind of like the models become more commodity over time, right? Like someone could say, oh, for a few months, I want to try out the IBM model. I'm now going to try out the Llama model. I'm going to go back to the IBM model. Like we're living in a world where it seems like increasingly the models will be things that we kind of like switch in, switch out, kind of at will. I don't know if you agree with that's kind of like how the future will look, or if it really will be, in the future, a customer will say, oh, we're going to build entirely on, the IBM model stack. And that will be kind of the future. It's kind of a question, I guess, for you about like how much software will become like the key platform, or if it really will be actually more kind of like an infrastructure thing where like we build on AWS and sort of the models are very interchangeable.
So I think that from experience of switching from one model family to another model family, it's very hard. So I think there is actually a substantial lock-in into a specific model, and it's primarily because of prompt tuning. And we've seen just by doing better prompt tuning for a specific model family, like a 30-40% improvement in accuracy, sometimes like 60. And then when you did that and you spent 3 months of your engineering team getting your prompts correct, and you switch to a different model family, all that prompt tuning work actually is not transferable. And so I think there is it's almost like, you are betting on a particular programming language, and then you're saying, oh, programming language or programming language, so I can switch from Java to Python to C#, and it's just, you just need to rewrite it a little bit. I think there is actually a quite substantial lock-in into the models. And so I think what will happen is that the location where the computation happens, that's totally commoditized. So if you're on Amazon, you run on Amazon, and if you want to run it in Google Cloud or IBM Cloud, then that's what you do. I think that the model families have a much higher stickiness. It's like the way skills and knowledge get trained in, it's not directly transferable.
Yeah, I don't know if I necessarily agree with that. I think the past, you're 100% correct. There's been kind of like a moat around specific models given the prompt template. But I think with things like, the model context protocol that Anthropic released that, again, supports Anthropic, but is bound to be an open source tool, and kind of what we're building, or what the community is building across agents, where you have to be able to rely on multiple models given inference costs and capabilities within your particular workflow. I think right now I think it's accurate, but I think going forward, model developers are going to be handcuffing themselves if they try to build an infrastructure around only using their models to support use cases, where it's going to be more so, what is the plumbing going to look like in order to be able to have interconnectedness with LLMs given the particular use case or agent. But I mean, that's just my opinion.
Do you think that this is it's a counter reaction to model vendor lock-in? Because that's usually what you see, right? It's like, oh, we have a cloud here, and then we build an abstraction layer.
Yeah, no, that's fair. I feel like model development became a trying to lock in, and then this democratization or this race to the bottom in terms of model development almost hinders model developers if they don't allow their specific models or their ecosystem to play well with others. I think that's where you're seeing the proliferation of open source models. It's driving a community, given that the community decides, what is good and what is bad. And from a commercial standpoint, it's more so, how do we make money? But I don't necessarily, again, my personal views, I don't think going forward, model developers are going to they're going to be able to lock people in and still have the adoption that they want.
Yeah, I don't know. It's going to be really interesting to see how it plays out. I know a lot of like engineer kind of types that I know are like, oh, well, in the future, like there's not going to be much prompting. We'll just run an optimizer and the prompt will be perfect for it, and it won't really matter. But like, and I don't know. I also know people who work, in this stuff who's just like, it's very hard to imagine that we're going to get that level of optimization where effectively the models become commodity because you can always optimize the prompt to get what you want. I'm going to move us on to our next topic. So really sort of interesting news came out this week on a new type of model exfiltration type attack. And I think, Wagner, you flagged this for us. It was a super fun story because normally we talk about, prompt hacking and how do we do stuff from just like the inputs and outputs of the model. But this is great because I think this is the type of attack that you see from time to time, which is a side channel, right? Which is we're going to just monitor a TPU chip as it does its thing. And then from that, we're going to extract all the intel we need to reproduce your model. So pretty interesting. And I guess, Wagner, I mean, you're the one who flagged it. Like, what did you find most interesting about this story?
When I read this story, I thought that the interesting aspect, and I started thinking about the money that and all the resources that take to train a model and to deploy to a TPU, for instance. And then these researchers, they found a way to use electromagnetic field to do a reverse engineering of the layers of the model that are deployed to that. And they do that by comparing with a data set they have of over 5,000 layer architectures. And so by trying like layer by layer, they can mimic one model to a different TPU, right? For with 99% of accuracy. So that was that caught my attention and say, whoa, that's something that tells a lot about how certain strategies may be at risk in terms of this kind of attack. And again, I'm advocate open source again, because that if you have open source, and then that will be a way to be less susceptible to this kind of attack. But yeah, that's what caught my attention in terms of how and last month, I think I saw also an attack that was published on PC World that was about something related, like exploring the HDMI cables to detect what people were seeing on their monitors. So I think it's interesting how certain attacks, they go beyond our like more immediate thoughts about how attacks may happen, and they're on exploring these capabilities of hardware, and also the electromagnetic field around them, and also these other properties and capabilities that are there, but sometimes we don't pay attention.
Yeah, definitely. I love this kind of collection of attacks. I mean, this NC State University report is also, it reminds me of like, there's a really old one from DEF CON a number of years ago where it listens to the sound your keyboard makes in order to extract what it is that you're typing, which I think is like really fascinating. I guess Volkmar, working on AI infrastructure, one reaction is like, this is cool, but like, is it a practical attack? Is it a security surface that we need to be worried about? Because, who's going to stand outside the data center, do this monitoring?
I think there are two questions. So one is like, what's the value of a model? Is the model structure in itself valuable? I don't think that, like, this is the one thing which, everybody understands the math. I think there's not huge amounts of gain right now in looking at the model structure. I think the true value are the numbers, right? So if you don't have the weights, then ultimately that's the information they turned into a model. That's the expensive part. The model structure itself is the cheap part. I think that there is, in computer science over the last, 5 decades, we figured out how to secure like computer infrastructure. So you have the same thing, extracting databases and database content out of computers. We have, cryptography now on pretty much every link in the computer system, so that you can even run it in the cloud. And so there's a whole confidential compute like movement where the PCIe link from the host to the GPU is fully encrypted, so that you cannot intercept anything which travels over it. And so I think we have very standard like defense mechanisms against just brute force attacks on the physical hardware. I think where we are, I think, a little bit laissez-faire today is how models get exchanged. And so the model in itself, in particular, if you look from a proprietary perspective, contain your business information, right? So let's say you fine tune it and you take your proprietary data and you stick it in the model. You don't want to, like, you wouldn't give your database to your competitors. And so you wouldn't want to give your model, which knows everything in your database, to your competitor. And so we are still in a world right now, I think, where we haven't really figured out what the end-to-end process of confidentiality around models is. And so there are pieces missing in the infrastructure, just like how we evolved to where we are today. Like, can I have fully encrypted models which only get decrypted, for example, inside of the GPU? Can I have, so this is the weights, this may be the code if I want to make that confidential. And then it also means like, the stimulus or the inputs and the outputs, are they making it, over the wire in an encrypted or unencrypted fashion? So we have the mechanisms. The problem is they are not pervasively like deployed or available in hardware or used, right? And so I think over the next couple of years, I think we will see much more like effort being put in to make sure that, we actually protect the asset in a much more stringent way. I mean, we have data at rest, everything's encrypted, data in flight, everything's encrypted, and here comes the model, right? And it's like, good luck.
Yeah, it's really interesting. I mean, if I'm hearing you right, it feels like a little bit like, as true with many things in security, it's like we have the techniques. Now the question is, can we get like uniform adoption in a way that actually offers security here?
And I think it's like a whole ecosystem of software just has been written, and it's kind of this race to the market. And now we are like, oh my God, like all that proprietary stuff, we are like wide open. And so I think we will actually start locking things down. And, like from an enterprise perspective, what we do at IBM, this is like, a good chunk of what's in X is like protecting your data assets, protecting your model assets, making sure, that you are actually compliant. And I think that whole workflow of building these things, it has been an afterthought because we just download the internet and train it in a model. But I think we are now getting into a world where there are really expensive assets which you must protect, and so like everything which follows in the enterprise will effectively be employed with AI.
Yeah, I think it's totally. I think it's like, and it actually ties to what we were talking about a little bit earlier, right? If like the trend is we've sort of run out of all the common data, right? Like there's also just like more proprietary stuff that becomes a component of how we go about doing this in a way that's like raises the risks here, right? Actually raises the incentive. Abraham, maybe I can ask you is like, so there are these kind of interesting security questions about, model exfiltration and all that. And, granted, of course, is like an open model. But I'm kind of curious about how you guys think about security on a release like 3.1. Is there a separate team that does that analysis? Just kind of interested in hearing a little bit more about how you guys think about that in the context of like an open source launch.
Yeah. So we think about to answer your question. Yeah, there's a dedicated team led by Ian Malloy focused on security, and they do a lot of work in terms of being able to better identify like vulnerabilities in the model. There's also a wide swath of safety and red teaming that we do, more so from the safety perspective, ensuring that our models don't harm. But one of the big things we've seen in terms of security, at least from our cybersecurity team, is that models are most vulnerable because, or the ways we found models are vulnerable is that in the training data we may be able to train on for instance, a large corpus of a language that's not in our intended use case. So if a user was to, prompt our model in that particular use case or that particular language, given that that's not in the scope of our security framework, it makes it a little bit more vulnerable to either jailbreak or to, get a response that maybe not is in scope of what the model should be used for. From the infrastructure standpoint, I'll be totally transparent. This is kind of out of my purview. In reading the article, it was just really interesting to see that, one, this was models on the edge. So things that are, TPUs are not necessarily typically used to inference, larger scale LLMs. Also, it was what I found interesting was this was a vulnerability specific to a infrastructure provider. It wasn't necessarily an external attack that was successful. So I think it just brought up the question in terms of, is this something where model infrastructure providers need to provide more robust guardrails around how potential bad actors inside the company could infiltrate their models. And then just to the point that Volkmar made, a lot of the models, the architecture of the model, i.e., the layers and other aspects of the model, they're usually provided as part of the open source community. So a lot of these things are on hand for people to use. So in terms of whether this is a risk that, we need to kind of dive into full scope, I can't say yes or I can't say no, but I think my take from it was, I think it opened up a little bit more of the question of how are infrastructure providers ensuring that bad actors inside the company aren't, trying to infiltrate any of the models that they serve.
That's right. Yeah. And I think it goes to a little bit of what Volkmar was talking a little bit about, which is, a number of these security issues are known security issues for just infrastructure, even before you get to AI infrastructure. And so, the insider threat problem is big in any case. And it's kind of just like, well, how much of this kind of folds into kind of traditional security work? I think this is one of the reasons I'm asking Abraham, is I'm really interested in kind of how like an organization decides to deal with safety and security on these models is really interesting. Like who's responsible for bits of this? And I think it's assigned in very different parts of the organization. It's like very interesting.
Yeah. So. And it's new. These are things that, we like, as much as AI has proliferated over the last couple of years, it's only, the Attention Is All You Need only came out, 7 years ago, and
yeah,
actually he came out 3.5 years ago. So we're still trying to figure out a lot of things.
That's right. I mean, one of the things I love to say on MOE is in the old days, and by that I mean like 5 years ago.
6 months ago.
So, yeah, that's right. So I'm going to move us on to our final topic for the day, which is Jetson. Background on all this is that NVIDIA announced a small, dare I say, cute little board supercomputer called Jetson for AI developers. Unlike the eye-watering price of an H100 or what will be the price of the GB200, this retails for a relatively cheap price of $250 and is this kind of handheld little board. And I guess, Volkmar, maybe I'll turn it to you is like, why is NVIDIA getting into this business, like this kind of hobbyist GPU business? And do you think it actually kind of like matters for the overall AI market at all? Or is this kind of a little bit just like Jensen wanted to do a fun thing and is releasing like a little board just because it's a fun end of year thing to do?
Yeah. So this is a continuation of something NVIDIA invested for many, many years. And so before the ChatGPT craze, like there was a massive investment of NVIDIA into autonomous vehicles. And so coming from that industry, we've been tracking that board pretty much. I mean, it came out, I think, 2015, 16 ballparkish, and has been like continuously receiving updates from NVIDIA. So this is really a board which is, for low power robotics. There is a version which has lots and lots of cameras being able to be attached so that you can actually put it on a robot, and it's cheap because it's made for scale. It's not running large language models, more like vision processing, planning, mapping. So it has a bunch of ARM processors on it, and then it has a bunch of has effectively an NVIDIA GPU. So I think the main benefit over all the other solutions on the market is that in many cases today, you train your models on an NVIDIA card. So you're living in an ecosystem, and then you can just move that ecosystem in production where you only run the inferencing part. And it's powerful enough that you can actually, you do camera processing, there are video encoders, et cetera, on these, on that one chip. It's a pretty low power solution, so you don't drain batteries. So you don't want to put an H100 on a robot simply because, your robot drives like 5 meters and is out of power. And so it's more of an embedded system on a chip thing. So I think the nice part of it is it's, now it used to be like around $500. Now it's down to, 250 or so. It's really affordable for, hobbyists, but also like if you want to build something at scale and you get a chip, for $250, you effectively can build a robot now. So like at least from the electronics part, I mean, the robot's missing, right?
Yeah, right.
So,
you at least got the board. Yeah. The robot is up to you.
Yeah. So the automotive part of that is a bit more involved, and it has like dual chips and has many more cameras, and it has ADAS compliant. And this one here is kind of the baby chip of that.
Wagner, maybe I'll turn to you on this. We've talked a lot about models getting smaller, but when we've talked about kind of like system on a chip, and we've talked about kind of like AI at the edge, it's often been in the context of like a mobile phone, right? Like we've talked about like Apple doing a new release. One of the things I think that's like pretty fun about this is that it's kind of like it's offered as just like, or it's marketed certainly as kind of like a tool for hobbyists, student groups that want to build robots or they want to do their own inference, like for their own experiments. That ecosystem I think is really interesting. And I guess I got kind of question for you is like how far you think that's going to go over time. Maybe the last thing I'll throw in is I've been watching this project by George Hotz for some time, this TinyCorp project, where he wants to basically offer everybody a petaflop. And I think one of the questions is just like, does it become cheap enough that everybody ends up having like a little GPU rig at home? I'm kind of curious about how you think about like that, because it starts to look quite different from how we do AI nowadays.
Yeah, this accessibility in terms of value, I think that it's the most important aspect in my understanding. Even that if we think about developing countries, for instance, in Brazil, $250 is like the minimum wage, a monthly salary. So it's not that cheap in developing developing countries. But even though if we consider that this is the cheapest right now, I think that opens possibilities and a lot of possibilities in those countries where people have a lot of creativity and this kind of hardware may allow them to think about like robots for agriculture or other interesting uses that the cost before this specific hardware was a blocker.
Yeah, that's right. Yeah, the kind of continual democratization is interesting. Yeah, definitely for international as well. I mean, I think that's a really big component of this is who gets to be able to tinker with some of these tools seems really, really important. I guess, Abraham, are you an AI hobbyist in your free time? I'm kind of curious if you would like buy something like this, play around with these types of tools.
I mean, it depends on who's asking the question. Yeah, I definitely in the old world, I definitely played a lot with it. I'm not as technically sound as some of the other team members here at IBM Research, but I find myself playing with the agentic framework B quite a bit. And when baby AGI came out a couple years ago, I found myself really kind of diving into it. So I don't know if I'd buy this per se, but I think just like the AI development is being abstracted to a level where it's a lot of plug and play nowadays. So you get a lot of, the skill set of a developer, although for like core LLM development may still be like, sound. But in terms of just a hobbyist, I think that skill set, can be a little bit lower. And I think this is kind of a pretty cool tool to help that, side of the fence in terms of, creating more models that you can run on the edge.
Yeah, absolutely. I think there's going to be just a ton of activity there. Well, great. Well, thanks everybody for their time today. Abraham, welcome to the show. Hoping to have you on for a future episode. Wagner Volkmar, always a pleasure to have you on the show as well. Thanks for joining us. If you enjoyed what you heard, you can get us on Apple Podcasts, Spotify, and podcast platforms everywhere. And listeners, we'll see you next week.